Okay, the Wilcoxon ranked sum test. The sign test does not consider the magnitude of the data. For example, whether a value of 1 point or 100 points below the median, it will receive a negative sign. One compares values of the pre-test and post-test situation. The magnitude of the differences is not considered. The Wilcoxon test considered differences in magnitude by using ranks. So, as we look through here, the sum tests considered in this section 13.5 are the Wilcoxon rank sum test, which is used in independent samples, and the Wilcoxon rank test, which is used for dependent samples. They sound like the same, but there's a little bit of difference between combined and ranked. So let's look at this. For example, the first test to be considered is the Wilcoxon rank sum test for independent samples. For this test, both sample size must be greater than or equal to 10. The formula needed for the test are given. Z is equal to R minus mu of the ranks divided standard deviation of ranks. Mu of the ranks is N1 times N1 plus N2 plus 1 divided by 2. And sigma R is the square root of this. R is equal to the sum of the ranks of the sample size, and so on down the line. So as we look at through here, 2 independent samples of Army recruits are selected, and the time in minutes it takes to each recruit to complete an obstacle course is recorded, as shown in the table. At alpha 0.05, is there a difference in times it takes the recruit to complete the course? We're given that the mean at each one is 19.67 and 14.27. So on the line. So let's look at the data. First, we're going to state the hypothesis and identify the claim. There is no difference in times it takes the recruits to complete the obstacle course. There is a difference in time. That's the claim. There is a difference in times recruits complete the obstacle course. Find the critical value. Since alpha 0.05, the test is two-tailed using z values of 1.96 and negative 1.96. And we're going to compute the test value now. Combine the data for the two examples and arrange the data in order and rank each value. Be sure to indicate the group. So in other words, one finished in 8 seconds, 9 seconds, and so on down the line. We gave each one Marines, and so on down the line. Now, if two scores are the same, so like here, Army and military both get the same, we'd rank them average of the two. So like this would be 8, this would be 9. We take the average of the two is 8.5, 8.5. This would be 9, 10, actually 8, 7, 8, 9. This would be 10 and 11, average of the two, and so on down the line. Now we're going to do is sum the ranks of the group for the smaller sample size. Note, if both groups have the same sample size, either one can be used. In this case, the sample size for Marines is smaller, so Marines would be 1, 2, so on down the line at 93. Substitute in the formulas to find the test value. Mu the ranks, N1 plus N2, so we got 11. 11 plus 12 plus 1 divided by 2 is 132. Sigma, putting those values in, we get 16.2. So our Z value is R93. Sum of the ranks minus 132 divided by 16.2, which is a negative 2.41. And we're going to make our decision. The decision is to reject the null hypotheses since negative 2.41 is less than negative 1.96. There is enough evidence to support the claim that there is a difference in times it takes the recruits to complete the course. So there is a difference. So if we look through here, we stated the hypotheses. There is a difference. Found the z values of the tables. Combine the table values in order. Sum of the ranks. Found the mean. Found the standard deviation. We'll come back to these formulas. And got our answers out. So that's what this summarizes with our formulas and everything. So let's try another one here. A researcher wishes to see if there's a difference in the number of jet airplanes for repairs. So we're going to in storage, repairs, and number of jet airplanes in storage. A sample of 5 here in storage. So we're going to rank them in order. So I'll keep my pen up here. Let's see if I can make it any smaller. So we're going to rank these in So we have 140. Across the left, that goes 149, 152, 179, 191, 432. Oops, I missed one here. I'm going to put one in here. Cross that one off. 208, 432, 647, 716, 1285, 1338, and 1480. We get 12 values. So this would be 1, 2, 3, 4, 5, 6. And I'm going to put I. And we're using 0.05 two-tailed test, so our critical values are going to be plus or minus 1.96. Our null hypothesis and our alternate. And the test they claim that there is no difference in the number of planes. There is no difference in the number of planes in the number of planes. This is the claim. There is a difference. So now if I did there's our critical value, our test value. Start off by finding the sum, and I'm going to use the in storage ones. Add up the ranks, get 3, 6, 10, 15, 22. So my R value here is equal to 22, since they're both the same sample size. Now if we go back to our values, we have mu of R is equal to N1, N2, and so down the line here. So mu of R equals N1, so it would be 1, 2, 3, 4, 5, 6. 6 times 6 plus 6 plus, I have to remember the formula here, plus 1 divided by 2. 12, 13 times 6 is 78 divided by 2, which is 39. Sigma R, so we're going to take a square root, N1 and N2, so it would be 36 times 13 divided by 12, square root of that. So really what we have here is square root of 39. Square root of 39 is approximately 6 point something, 6 point 3 or something like that, approximately 6.3. So now we would have the rest as we go through and find our values. Go back to our formula. We found that our z is r minus mu of r, sigma r. R minus this, so we got z is equal to 22 minus 39 divided by approximately 6.3. Negative 17 divided by 6.3. So I might have to pull my calculator out here to get our answer here. If we did this on the calculator, we got negative 17. We get negative 2.7. And negative 2.7, if we think about our critical values here, negative 1.96, negative 2.7 is over here, so therefore we would reject the null processes and say there is a difference in the two types of storage in the two. There is a difference between the two. Now, that kind of finishes up the Wilcox test, and I'll save that right now.